All right, today we're going to talk about what a definition is in math. Definitions in math are very specific, and there are some steps that we need to follow in order to create a good definition. All right, so the first step is to classify your term. What is it? What exactly are we trying to define? Use very clear language with very easy to understand terms. For example, don't use a word that the typical person in your class would not understand. That defeats the purpose of a definition. All right, the second step is to differentiate your term. How does it differ from others in that class? So if you're talking about a triangle, maybe you need to be more specific about what type of triangle you're defining, okay? The last step is to test your definition by looking for a counterexample. And I'll come back to counterexample at the end of this video, okay? All right, so let's look at an example for this. So it says, following these steps, classify and differentiate each term. So I have an example of a definition here, and we're going to determine whether or not this is a good enough definition. So we're talking about parallel lines are lines in the same plane that never meet. Okay, so first we want to figure out what exactly am I defining? What am I classifying? Well, I'm determining what parallel lines are. Okay, now how am I classifying them? How am I making them more specific? Okay, I'm saying that they are lines in the same plane. Now, the reason it's important to say same plane is because if we're talking about lines that never meet, and we don't have the same plane in there, it could get confusing, okay? Now we're going to differentiate. How is this different than like any other line? Well, they never meet, okay? So when determining if it's a good definition, we want to make sure we are being very specific, we're classifying what it is, and we're differentiating it from other things. For example, in this one, it would be lines, okay? All right, we also want to remember and use the same idea when we create our own definitions, okay? All right, so the next thing we're going to talk about is what I said we were going to come back to at the beginning of the video, is what is a counterexample, okay? A counterexample is an example that proves the definition to be inadequate, all right? So for example, I have a definition down here that says a square is a figure with 4 equal sides, okay? Yes, that's true. A square does have 4 equal sides. However, so does this shape, and that is clearly not a square, okay? So in order to determine if this is a better or a good enough definition, we would in this case say no, because we were able to find a counterexample. In this case, it would be this figure down here. All right, so in order to make this a better definition, we would say a square is a figure with 4 equal sides, just like it said before, but we're going to add something. And 4 right angles. Okay? That way we know that we are being as specific as possible and we are differentiating it or making sure it's different than another 4-sided figure. Okay? All right. That's all I have for what a definition is in math. Thanks.